What's poppin', dogs? Mr. Allen here, solving some triangles, some non-right triangles here. So we're going to be using non-right triangle trig to solve triangle ABC, or find all the missing sides and angles. So it says in triangle ABC, the measure of angle A is 27 degrees. I'll go ahead and mark that. The measure of B, or AB, segment AB, is 22 feet. And then, or the length of AB, and the length of BC is 12 feet. Okay. Interesting. Well, let's identify first what kind of situation we have here before we find all the missing sides and angles. I have an angle, a side, and a side. So I haven't, maybe I shouldn't abbreviate this one. Angle, side, side, right? That's the situation I got going on here. All right. And we got to be careful with the angle side side situation, because we could really make an angle side side out of ourselves if we aren't checking things, okay, and being careful. So this is the one where it leads to the ambiguous case, right? So we could have one triangle, we could have two triangles, we could have no triangles in this situation. We just got to see how it works out. Now, because I have an angle and a known side across from it, I can use law of sines, okay? And I'm going to prep this as if I'm going to possibly have two triangles here. I'm not sure exactly how it's going to work out. We'll find out. But first thing I'm going to do is I'm going to set up my super proportion, okay? So I've got fraction equals a fraction equals a fraction. Okay, and I'm going to leave myself some room over here in case there's a second triangle that I need to solve. All right, now I know across from angle A is 12. So I'm going to put that one in the middle here. So I got sine of 27 over 12. The reason why I put that in the middle is so that when I cross multiply, I can just cover this one up, deal with these two fractions. When I want to do that one, I just deal with these two fractions. They're already next to each other. I don't have to rewrite stuff or kind of hop around things. Strategy I like. All right, this is side B right here. I'll write it right there. And that was C. Okay, cool. We're good. So I don't know the measure of angle B, but we'll go ahead and put it here. So we'll say sine of B over little b. And then we got sine of C over 22. Okay, so I have my whole situation set up here, right? Now, let's see here. I could have set it up with the sines in the numerator like I did in the side lengths in the denominator, or flipped, okay? So you can do that. If your teacher does it the other way, it's no different. You're just going to cross multiply and solve still, okay? Just make sure you're consistent. It's all sines in the numerator, all lengths in the denominator. Cool? Or vice versa. So it looks like what I have to do here is I need to solve for sine or for angle C first, right? That's the only one that I know information on. Here I have nothing for either of them, which is a bummer, okay? So we'll do that. All right, so I'm going to cross multiply and solve here. I'll keep it all in, you know what? Actually, I'll do this in green here. We got enough colors. So this is going to be in green. We got 22 times the sine of 27 equals 12 times the sine of C. We're going to divide by 12 on both sides. And now I know I could simplify the 22 and the 12, but I won't. It doesn't always happen, so why even bother? It's all going in the calculator anyways. Equals the sine of C. Now, how do I get C by itself if it's sine of C, right? It's in that sine. Well, I can take the sine inverse on both sides here, sine inverse, and that's going to cancel those out, leaving me with just C. So this is what I can now type into my calculator to figure out that angle, okay? So first off, let's make sure we're in the right mode. I'm in degree mode, as you can see right here. If you're not, make sure that you change that, and then you can hit second quit to get back to the main screen. So I'm going to hit second sine, and then alpha x to get my fraction, or you could do alpha y equals, whichever works for your calculator. Some of the newer ones have the alpha x thing, and it's pretty dope. So you got 22 sine of 27. Close my parentheses, arrow down 12, arrow out, and close my parentheses, hit enter, and we get 56.337 degrees. Okay. So C, the measure of angle C, is 56.337, so 34 degrees. Okay. So there we go. We got one of them. Now here's the thing, is there is the potential for a second triangle to exist, okay? And you can either check for it now or check for it later. It's up to you. I like to check for it now, okay? Because I might forget later. And it involves this angle here. So there is the potential, and I'll do this now in, we'll say in blue. Actually, I'll keep it green because I feel like it relates to this angle. So there's a potential for a second triangle to exist, and I'll show you why. This angle right here is not fixed. Therefore, this BC side could swing in right here, okay? And it could look something like, let me try and get it as accurate as possible here. I think I like that. This could be a new side or a new version of a triangle here, right? This triangle right here with this obtuse angle, okay, which I don't know. But there is a potential for that to happen, okay? So what is that potential angle? How do I get that, right? Well, this 56.34 degrees right here would also be right here. And why is that? Well, if this is 12 feet, and I'm just swinging that side in, making the same triangle, this is also 12 feet. Therefore, it's an isosceles triangle, and this angle is also 56.34 degrees. So what is this angle going to be right here? Well, these two should add up to 180. So what I'm going to do is do 180 minus this guy right here, and I've got 123.66 degrees. That's a new possible angle there. But we do need to make sure that this triangle could exist, right? If there's enough room for this other angle up here to party, if you will. Okay, so up here now, what's this angle going to be? Can I even get that? Well, if I took the 27 and the 123, I add them together, there's got to be enough room for it to exist. 180 minus those two would tell me. So I'm going to do, we'll do, let's see here. Actually, we'll do plus the 27 and then hit enter, 180 minus that. Yes, there is room to party. So we got 29.34 degrees, okay? So there is a second triangle here. Look out, right? We're going to be dealing with all those. So time to get back to work. What's the last thing we needed in our first triangle here? So I'll keep this in, let's do this. Let's say triangle number 1. We had, we found that measure of angle C, that was 56.34 degrees. We also need side length B, and I need this angle up here. So let's get the measure of angle B right now. Measure of angle B. How am I going to get that? Well, 27 plus 56.34, 27 plus 56.34, and then 180 minus that is that angle right there. And you might be like, bro, did you just round and then use that rounded value? I did. And the reason being, and I know you only round once, right? But the reason being is they need to add up to exactly 180. So I don't want to, have a situation where they don't. I've decided that that angle is 56.34, so this one needs to jive with that 66 degrees. Boom. Boom. These are my final answers, okay? So I'm using them rounding for the final answer there. And the last thing I need is side B or AC, but we'll just call it lowercase b here. So let's get lowercase b. Don't have that one yet. Got to get it. So we're back over here. Whew, after all that, okay? Back over here. Well, I'm going to come back to my wonderful super proportion that I have, right? Sine of b here over b, I had nothing, but now I have angle B. So let's write that down. Okay, let's write it down here. I'll go in blue, I guess, for this. So sine of angle B, that's 96.66 over side B. Okay, so side B here, we don't know, equals, and then I've got myself sine of 27 over 12. Okay, so there we go. Now I'm going to cross multiply and solve. So we got 12 times that guy. 12 sine of 96.66 equals B sine of 27. Now and then we got divide by sine of 27. Almost forgot. Okay. Now, what I like to do is I'm going to use this rounded value here. And the reason being is that I have stated that this is the triangle, right? We found that angle. They have to add up to 180 degrees. There's justification for using that. So 12, I know it seems crazy. I know I feel like I'm, not yo-rolling right now, but I feel like it's the correct way. It's justified. 96.66, close them over sine of 27, close them, and I've got 26.25. Okay. feet. Lovely. One triangle, done. Time for triangle number 2. Woo! All right, so triangle number 2. Let's write down what we have so far. Triangle 2. I've got this guy right here. That would be the new C, right? Measure of angle C is 123.66 degrees. What else do I have? This guy up here, that's the measure of angle B. That is 29.34 degrees. And the last thing that we need here, because I have this is 12 already, I just need the side B again, just a little b. Right, we're solving for the same things. Look at that, same things, right? We're just getting some different numbers, okay? So how are we going to do that? Well, I can actually use this here and this here, but now I just have a new angle, okay? So same proportion, but instead of 96.66, I'm using the 29.34. So we got sine of 29.34 over B, which I don't know, equals sine of 27 over 12. Cross multiply, we get 12 sine 29.34 equals B sine 27. Divide and divide sine 27. So we get B equals all that jazz, right? So alpha x, then we got 12 sine 29.34 over sine 27. 12.95 feet. There we go. Boom. Excellent. Love it. Fantastic. Good stuff, you guys. Good stuff. All right. So there we go, man. It's a pretty awesome problem. It's a lot. I don't know what else there is to say, but check for 2 triangles, right? However you want to do it. If you want to wait till the end to check, maybe just at least write yourself a reminder, like check for a second triangle. 2 triangles is this. These are beasts of problems, right? It's a lot. They ain't no joke. They ain't no joke. So anyways, thanks for watching, guys. If you stuck around to the very end, and have a wonderful day.